Dunder methods? Ah, nice question. Can I somehow learn about Dunder methods? You are at the right place. Hello everybody. Today you are gonna learn about Dunder methods. I'm Saion Gupta, founder at 10x Coder Kids, and let's get started. Let's get started. So Python has several magic methods. You typically hear them being referred to as Dunder methods. So these are like magic methods. So these methods carry out a procedure known as operator overloading. That it means that providing extended meaning beyond the predefined meaning to an operator. You'll see this in in example in further in this video, right? So Dunder methods begin and end with two underscores. The most popular one you may have come across is the init method, where you define all your properties of your class that you will use. So whenever we create a new object in Python, we implicitly create a related object, since all classes inherit from object. So the methods defined in the object class are inherited by a newly created class and are used in various situations, like when an object is printed. So there is a predefined object class from whose all methods and properties are inherited by our class that we define. And like for example, when we print our object of any class that we created, then what will happen? It uses the one of the methods that was inherited, and that is called wrapper. So it uses the wrapper method whenever we try to print an object. It uses the wrapper method to display this information that you see over here. So we create a class car. We're just not giving anything, we're just giving pass in this, right? Then we have car equals to a car object, and then we are printing car. So now when we are printing car, it will take the use the repo method that was inherited by the car class from the object class. So basically, to print this, the repo method that was inherited by our car class from the object class is used, right? So we'll just comment this, and we can also do we know that it already inherits from our object class, but you can also specify that this is inheriting from your object class. So you can specify, or it already does. So specifying does not make a difference, specifying or not, because the car class is already inheriting from object, so we don't need to specify that this is inheriting from object, right? Pretty cool. So how did the code above know what to print? How did it know how to print this? Simple. The object, which is the parent class of all classes in Python, has a dunder method. Dunder methods are methods that start with underscores and end with underscores, two underscores, right? So Python has so the object, which is the parent of all classes in Python, has a dunder method called repo, right? When we call the print statement, it makes a call to the repo method, as I told you, from our car object, which was inherited from the parent class object, and returns a value back to the main program, right? And that is being printed. Very, very, very cool. But a child class can override the parent class, so it can override the parent class. All we have to do is create a method with the same name in the child class. So you can override that dunder method and return something else. Like, so now whenever we try to print car, it will call your repo method that you just overrided, right? So the object class repo method came, and then you overriding it with your own repo method. So now from the object class, the repo method was inherited and it came in the car class, but we are overriding it and creating our own repo method, and we are seeing that self, and then there's a property class, right? And in that there's a property call name. So this will basically give you the value that you give over here, the name of your class. So now our repo method is returning a name of our class, the string type, right? So in we have given quotes over here, so we have done formatting, string formatting, right? And it is just giving us the name of our class, that is car. So whenever we print car, instead of getting this whole thing, we're just gonna get our what we say, we are just gonna get our car class name of our object class, right? So whichever class object it was, that class name will come. So car is an object of a car class, so it gave us car over here. But I'll just want to show you what all we have in class. So when we print class, what happens? It gives us class main dot car. So or when we print class, we have, it will show us class main dot car. And if we just access its qual name, we just get this much that I have highlighted, this much, this, oh, this much, right? So we only get this much when we access qual name. So on class you see, your our class is an object, right? Because it has properties like qual name. But we are, when we are printing it, we are getting this. So there is also a dunder method put on a class property, that when we print the class property, we should get this. And when we are accessing properties from our class object, then we should get that property's value, right? So pretty cool. So we can also use the string underscore underscore str underscore underscore pronounced as stir, right? So we can also use the stir dunder method to create a string representation. The stir method returns a human readable string that provides more insightful information about the object, right? So it is more or less same as the repo, but there is a difference that you'll see over here. So we have just like we have just given instead of like what we say repo, we have just given string, and then we are returning this. So what we'll get this string over here, right? So we'll get this string over here, this stuff that the string method dunder method is returning, that is car, the qualified name, right? The qualified name of a class, that is the car class. So we are getting the car, right? We are getting car returned because this is an object of a car class. So the repo method serves as a backup behavior if the stir is missing. Thus, when you call print, it first looks up for stir. If it does not find stir, it calls repo. Very cool. Next, we have some math dunder methods. So when we create expressions, we use special symbols known as operators. If we wish to use operands in an expression, then it must have a math dunder method the operator can use to evaluate the expression. Without creating a math dunder method, Python would raise an error. So if you see over here, if I just try to add so this is a random numbers class, and in the init method we are just creating two properties a and b, and we are setting the values whatever we get. That is, for this set a, it is for 2, it is 2 and 4, and for set b it is 3 and 5. And when we just try to print set a plus set b, this will give us an error because Python cannot exactly understand what we are trying to add. We're trying to add two objects, but what we are trying to add in that, it is not able to understand. So we get an error. That type error unsupported operand types for plus, random numbers and random numbers, right? Pretty cool. Of course, we could simply create an add random numbers method in our class, but a better way to solve this is use the add Dunder method. This way, we can use the plus operator with our random numbers object. So you just see this, how powerful Dunder methods actually are. So we have the same class, the same init method. We have just added this add Dunder method. That will get one thing, that is other. So we'll get other in this, and we'll write if not is instance of other random numbers. So if other is not a type of random numbers, right? So it is not in type of random numbers. So the data type of other is not the same as random numbers, then it will just return not implemented. But if it is not, if it is the other is of type random numbers, then it will come over here and return random numbers object, in which we will have the first thing other dot a plus self dot a, so whatever was our a plus the others a, and other dot b plus self dot b. And then we also have the repo method that will just give us the qualified name. So what we are doing self dot class dot qual name, right? And then it will just call, right? So it will just call. So what it will do first, it will give the call name, so that is random numbers. So it is giving us a string, so random numbers. Then it will add that one parenthesis. Then it will add self dot a. So whatever is self dot a, so self dot a is whatever we pass, like for example 2, and self dot b for example 4, right? So whenever we try to print our object of our random numbers class, we'll get this, like this, a and b over here, right? But whenever we try to add two objects of this same random numbers class, then what will happen? So then what will happen? Then it will give us, like for example, if we try to add these two, so then it will give us 2 plus 3 5, and 4 plus 5 9. So it will give us random numbers 5 and 9. So it will give us an object of our random numbers class, and it will have 5 and 9, right? Pretty cool. And then we are printing set a plus set b, so we are getting random numbers 5 and 9. And when we are printing, we logically get an object of our random numbers class. And whenever we are printing an object of a random numbers class, then it will give us the qualified name, the parenthesis, self dot a, that is 5, and self dot b, that is 9. So it will get random numbers 5 and 9. But the thing is, if I try to do, for example, set a plus 3, then this won't work. This is not going to work. It is saying that unsupported operands for random numbers and int, right? So this is checking if it is not an instance of random numbers. So if others is not an instance of random numbers, it will return not implemented. So if I try to do 3 plus 3, no. Okay, let's just leave it. Okay, let's just leave it right now. So right now what we are able to do, we are just able to add our objects. So when we call random numbers object is on the left side of the plus operator, then Python will call the add method. So when the random numbers object like set a is on the left side of the operator, it will call the add method of that left side of the object that is on the left hand side, right? So the method on the right hand side of the operator is passed as the other parameter to the left hand side's add method. So in an example, we prevent our object from adding objects that are in random number instances. Let's see another method that will allow us to multiply our numbers with integers. Now see this. So over here we have our add method. So we are able to add with other objects, but we also have this multiply underscore underscore mul underscore underscore. In this also it will take another other. and it will just check if not instance of int. So if it is not an instance of an integer, then we'll just return not implemented. But if it is an instance of an integer, that means if it is of type integer, then we'll just return random numbers self.a into other and self.b into other, right? So, and when we try to print this, we'll get an object. So we are doing set a into 3, so it will give us random number 6 comma 12, right? For it 12, yeah, so 6 comma 12, so we'll get 6 comma 12. And when we get 6 comma 12, then we are trying to print an object of our random numbers class, so it will call the repo method, and it will give us this over here, that the qualified name, that is random numbers self.a 6 and self.b 12. So in the end we get random number 6 comma 12. So you see this is working perfectly fine, but there are some drawbacks also. Again, notice the random numbers instance is on the left hand side of the operator, and yeah, so it is on the left hand side over here, the random numbers object. But what if we move it to the right hand side? So if I try to move it on the right hand side, if I do 3 into set, what will happen? An error. So we get an error. Why do we get an error? The reason why didn't it comment? Oh yeah, just a second. Yup. So the reason for this behavior is because math dunder methods are called when the object is on the left hand side of the math operator. So if you want to extend the functionality, so you can also call the object on the right side. Then you will have to define the reverse dunder method. So if you want to extend the functionality and you also want to multiply like 3 into set a, then what you have to do, you also have to define a reverse multiply method, that over here is our mul. So in our mul, we're just calling self.mul and other. So our mul will get other as the left hand side, right? So it will check that if it finds it does it find an object of random numbers on the left hand side? No. Checking on the right side, it does find it. So now it calls armor. Armor will get other as the first argument, so it is getting 3. As in other it is getting 3. We just call self.mul and pass it other. So now in other we got 3 over here, and this will just return us random numbers. It will just return us an object of a random numbers that is being further returned by armor that we are getting. And when we try to print that, the repo method is being called because we are trying to print an object of our random numbers class, right? So we are trying to print an object of our random numbers class, so the repo method will be called, and this will return random numbers bracket parenthesis, and then it will give us 6 comma 12 and parenthesis closed. So you'll get random numbers 6 comma 12. Very cool. And this was it, guys, for dunder methods in Python. I hope you guys liked the video. Thank you guys. Bye. Subscribe. Don't forget to subscribe.